Hey pre-calc. So to begin our second unit of the year, we are going to be talking about what we refer to as parent functions. And you'll see as we go through this, we have a few different parent functions that we will talk through. But our point is, it's really useful and necessary for us to know what our parent functions are, so that when we have transformations that are happening to them, like if they've been shifted to the left or right or up or down or whatever other transformations we will talk about in a few days, we will have a nice baseline to refer to in order to help us understand like how our graphs are being transformed. And so today our only focus is to just graph each of our parent functions. And in order to graph, we're just going to go ahead and fill out an XY table for each of these functions. And so let's go ahead and start with the function we see on the left now, which is y equals x. And I'm curious, you should be able to tell me what type of function this is. And so I'm going to ask you, what type of function is y equals x? That's right. Hopefully you're able to tell me that this is a linear function. This is the equation of a line. The reason we know that is because our x, its exponent is just a 1, which means that we have a linear function. And so normally when I'm trying to decide like what x values to plug in to my function, pretty much every single time, I'm going to go ahead and just start with -2, -1, 0, +1, and +2. And I'll give you a second to fill that out in your own parent functions toolkit while I kind of explain why. For the most part, many of our graphs really center around the origin, which again, the origin is the point 0, 0 on our graph. And so picking x values that are a little bit to the left of the origin, a little bit to the right of the origin, and then of course with an x value of 0, that's going to give us a lot of information and kind of show us like where our graph is coming to be. Now in order to find like this f-vex column, which is our y column, what we are going to do is simply plug our x values that we decided on into our function. So for example, like if we plug in -2 for x, we get y equals -2. And so this is actually really easy for linear functions, and I don't want to spend a ton of time here. But you'll see that, yeah, exactly, right? If we plug in an x of -2, our y is going to be -2. And it's going to be the same thing for each of these x values. Plug in -1 for x, we get -1 for y, 0, 0, 1, 1, 2, 2, etc., etc. Now that I have my table fill out, I can actually go ahead and plot these points. So -2 on the x, -2 on y, -1, -1, 0, 0, 1, 1, and 2, 2. And we can see when we connect our dots that that is how a line is formed. Excellent. We know this. Let's go ahead and try another function that we're actually kind of familiar with based on what we've been learning so far. And so if we look on this graph over on the right, you should 100% be able to tell me what type of function y equals, and I don't want to give it away, what this function is. Yes, it's our absolute value graph. We talked about it at the end of last unit. We actually went ahead and graphed it as well. And so I'm going to go through this one a little bit more quickly as well. Remember that the absolute value represents the distance of a number from 0. And so again, if I'm starting with -2, -1, 0, 1, and 2, when I do the absolute value of -2, so y equals the absolute value of -2, right, the distance from 0 is 2 units. So essentially what our absolute value is doing is making whatever's inside of our absolute value positive. So the absolute value of -1 is +1, 0, +1, +2. When we graph those points, we see what looks to us like a V-type shape. A V shape. Excellent. Let's go ahead and move on. Again, we've seen both of these functions before, so I'm going to move on to y equals x squared. This is going to be a quadratic. We also know it as like a parabola. And again, I'm going to start with -2, -1, 0, 1, and 2. Now, one thing I will say, when it comes to graphing parent functions and just like functions in general, usually we only need 3 key points. But I'm kind of focusing on a few more key points for some of these functions so that we can really see what the graph looks like as we plot more points. But what's super vital for us is that we have these key points in our table, because these are key points we will need to know in order for us to be able to graph our transformations. So that's why we're doing this in the first place. When I do y equals -2 squared, I get a +4, right? -2 times -2 is +4. -1 squared is going to be 1. 0 squared is 0. 1 squared is 1. And then +2 squared is +4 as well. And we know what a parabola looks like. But again, what's cool is going back to just plugging in some x values into our function to see like how we get our y values and how the form or shape of this graph really comes to be. And so when we plot these points, we see our quadratic. Nice. And again, I know I'm kind of going through these a little quickly, but again, we've seen these before, and I appreciate you following along. Let's go ahead and move on to this function here. Y equals the square root of x. We know what a square root is, and that's exactly why we call it a square root function. Now, up until this point, I've been plugging in -2, -1, 0, 1, and 2 into each of my functions in order to get my y values. But I want to stop for a second and think about like what would happen if I plugged in -2 for x. What would happen if I was trying to find the square root of -2? Now give us a second to think and share our thoughts. Yeah, right. Remember when we talked about the quadratic equation just in this past unit? And whenever we had a negative number underneath our square root, right, that made it complex. That made it imaginary. We can't take the square root of a negative number. And so for sure, thinking about that, I'm not going to use -2 and -1 as x values to plug into my square root function. What I can do is plug in 0. Because the square root of 0 is just 0, right? Because 0 times 0 is 0. I can also plug in 1. The square root of 1 is just 1, because 1 times 1 is 1. Now you might be thinking, hey, like let's just go ahead and plug in 2 for x. But I want to think smart here. If I asked you for the square root of 2, right, you would probably need a calculator to tell me what that value is. And again, when we're trying to graph these functions on like this coordinate plane, we want really nice crisp points. We don't want to like graph at some random decimal, right? And so I want to think smart here. If I'm taking the square root of a number, probably makes sense for me to pick an x value that is a perfect square. 0 and 1 both fit that bill. The next perfect square that I know is a +4. And when I plug in 4 for x and take the square root of 4, I'll have you tell me, what do I get for my y value? Excellent, right, the square root of 4 is 2, and so I have my 3 key points. I'm going to stop at 3 and go ahead and graph these. And so I have 1 point at 0, 0, 1 point at 1, 1, and then 1 point at 4, 2. And we see that when we connect these dots, I did not do a good job at connecting those dots. The shape of our square root function come to be. And we'll talk much more about this as the year goes on, but it's just very, very important right now that we understand what this function is called, what it looks like y equals the square root of x, what it looks like when we graph it, and then of course our key points that we are filling out in our table right now. Let's go ahead and move on. We only have 3 parent functions left. And so y equals x cubed, and so this is going to be a cubic function because it's y equals x cubed to the 3rd power. Here again, I'm going to be able to go back to normal. There aren't going to be any issues with what I plug in for x. So I'm going to do -2, -1, 0, 1, and 2. When I plug in a -2 and cube it, right, a number that's negative, well, I'll say it this way. That's going to be -2 times -2 times -2. We're for sure going to have a negative number, and then we think about 2 times 2 is 4. 4 times 2 is 8, and so -2 cubed is going to be -8. Same thing when we plug in -1. -1 cubed is just going to be -1. 0 cubed is just 0. And again, if you're struggling to see exactly where I'm getting these points, you are totally fine and free to use your calculator and literally plug in like -2 cubed or 0 cubed. But I'm going to go ahead and continue. 1 cubed is 1. 2 cubed is 8, right? We just did that work, but it's going to be positive now. And so when we graph these points, -2, -8, wow, that's way down there. -1, -1. 0, 0. 1, 1. And then 2, 8. We begin to see what our cubic function looks like. Connect those dots. Boom. This is the general shape of our cubic function. On the contrary, y equals the cubed root, this is our cube root function, is going to be a little bit different. And so let's say we plug in, if we're taking the cubed root of something, right, I don't know the cubed root of -2 because it's not a perfect cube. But I do know the cube root of -8 is -2, right? It's exactly the opposite of what we literally just did. Cube root of -1 is -1. Cube root of 0 is 0. And I can do 1, 1 again, then +8, +2. All right. I'm going to pause for a second, make sure you can write that, and then I'll have my points plotted when we continue. All right. You can see that I have plotted each of these points on my graph, and I've connected the dots. And one thing you notice is that it actually looks super similar to our cubic function here on the left, but it's just been flipped a little bit. It's been rotated around our origin. And that makes sense given the relationship between x cubed and the cubed root of x. Nice. Just have one more parent function. Let's go ahead and talk about it. Y equals 1 over x. You'll notice that this function is a fraction. Whenever we have our variable in the denominator, which we see here, our x is in our denominator, that is when we have a rational function. When I say rational, that just means fraction. So it makes sense. This is a rational function. And the key here is that, right, if we were to plug in 0 for x, we'd get 1 over 0, which is undefined, right? We can never divide by 0. And so at an x value of 0, I'm going to draw this vertical dashed line saying, hey, my function's never going to be defined here. Never, never. And we'll talk more about rational functions later on in the next unit. Something else that we will talk about a little bit later on as well is that there's actually another like horizontal dashed line, or as we call an asymptote, for this graph. And those are actually going to be like considered parts, like key parts of our graph that we need to have. The only two key points that really like matter for us is if we plug in 1 for x. We'll start with -1. 1 divided by -1, that's just -1. Plug in a +1. 1 divided by +1 is just +1. Graph that point. And then we can go ahead and connect our dots. All right, you can see I've done that, and it looks a little funky, right? We've never talked about a rational function before, but that's okay. Again, we are just focused on the key points and the general shape.